VLPSos here. This is a video lesson for Python programming, masking collision. This lesson file started as stub2. We're going to run this program and see what it does for us, and then take a look at the code to see how we accomplished it. We have a screen with a bunch of weird blue shapes drawn on it, mostly at the top. I can click anywhere on the screen, which creates a little white line we'll call a dart, and that dart moves up until it collides with one of the blue shapes, and then both the dart and the shape are erased. There are many shapes. They're drawn as polygons with 5 vertices, and those vertices are chosen at random by the program, so that's why they're so irregular in shape. We can see collision must be happening between the tip of the dart, or the top endpoint of the little white lines, and whatever blue polygon is hit. A technique called masking is determining which polygon is hit, and that involves drawing all the polygons on a separate surface that the user does not see. So we have 2 surfaces in the technique of masking. One where we draw all the polygons as, in this case, blue objects the user can see and interact with. This other surface that is the same size has the polygons drawn in the same place or the same shape, except that the color is unique for each one. Each one of these has a unique masking color. I've implemented the space bar so that we can take a look at this second surface, and we can see that all the polygons are drawn with their own unique color. So the collision is happening by testing the tip of each dart and determining what color that tip is interacting with, or the color on the masking screen at the tip of each dart every frame. If the tip of the dart detects that it's at a location that is not black, then it must be interacting with one of the polygons. It must have reached one of the polygons. And we can determine what polygon it's reached by taking that color on the mask, going through all of the existing polygons to see which one has that masking color. Once we've matched the masking color of the polygon with the color that was detected at the tip of the dart, then we've determined which one was hit, and at that point we erase both the dart and the polygon. The interaction is pixel perfect. We have irregular shapes here so that we can test how accurate this kind of collision is working for us. Let's take a look at the code file. We have 2 classes being written at the top of the code file, one for darts and one for bricks. Make note that the brick attribute, or an attribute of a brick, we have a point list to determine the vertices, and we have its masking color as an attribute, so that this masking color is the one that needs to be unique, so that we know which brick is being interacted with when we're trying to find the object that has the color that the dart detected. We have a function called findMask that was defined independent of the main function we'll get to in just a second. In the main function before the frame loop, we have 2 dictionaries, one for darts and one for bricks. We don't make any initial darts. Darts are created on a left mouse click. Bricks are made by for loop in this case, which involves finding a location at random, generating a point list with some randomness to make the shapes all pentagons with 5 points, but then also finding a unique masking color. That function that was written independent is called findMask. That's the process that we look to find a unique color for each of these instances to have as its mask. Before we get into that technique a little bit further, we have some basics. We create a dart in the frame loop. We move only the darts very simply. We're going to check for collisions and interactions and take a look at that in detail in just a second. We also draw the bricks and darts with these code blocks here in the frame loop and compose the screen and, of course, the event queue. Let's take a look at a little more detail in the code blocks for that masking technique. And it starts with this code block here called make the mask. Making the mask means that we have a surface that is going to be kind of like a mimic of the screen. And on that masking surface, everything that can be interacted with is going to be drawn there. Now what's on this masking surface is all of the polygons. So we've created a surface called mask surface. We fill that with black, erase it each time because it can change. And then we go through the bricks one at a time. We iterate through our bricks, the polygons that the user can see. And as long as those bricks are active, meaning they're turned on, we want the user to see them, then we prepare the list of vertices because they have a location and then points relative to their position based on the overall location. So that vertice list needs to be prepared with this code, and then it draws the polygon at the location with all of the vertices in the relative space. Once the mask is created, by drawing those polygons not in blue but with their masking color, then we have the mask that we can color check on. Color checking on the mask is in the code block for collision. So here we have the check for collisions and interactions. That process is a process of iterating through all of our darts. We need to check every frame whether every one of those darts has collided with or is interacting with anything other than the black screen. We do that by assigning a variable on the masking surface a call to the getAt function, which will get the color at the location on the surface that you're working with. And if it does have a color, then it gets something other than black, meaning it's detected something other than the backdrop. Then we go through the bricks to see what brick has that color as its mask. So that condition is here. If the color at tip, the color that was just detected on the masking surface, is equal to the masking color attribute of the current brick that we're with this key called brick key, then we turn both the brick and the dart's active attribute Boolean to false. Now, when this Boolean is false, then it's not drawn to the screen and we can no longer interact with it. This program does not erase or delete from the dictionary those that have a false active attribute. That would be wise because when we create a whole bunch of darts, they don't actually go away. They remain in the dictionary, but we don't see them and they can't be interacted with if their active Boolean is false. The last thing to show you some details of is how each instance got its own unique masking color. Masking here is a variable that we assign to be a call to find mask. The find mask function has been written here, and the comments describe what this code block is doing. Find mask creates a new random color tuple to use as a mask. So we start by finding a random color, by assigning red, green, and blue, something random from a range of 0 to 255. Once we have that random color, it iterates through the dictionary of already existing colors in the collection of bricks, to see if that color has already been used as a masking color. So if that color has already been used, it continues to create new masking colors until it finds one that hasn't been used and returns that color. So this function is generating a new unique masking color that hasn't already been used in the dictionary. This is a slow process and is inefficient. Sometimes when masking is used, it's not done this way, but this serves our purposes here, and we can create as many bricks as we want, and it'll find a unique mask for each one of them. Now you have seen how masking collision can be implemented by drawing on a separate surface the mask, all objects that can be interacted with in their own masking color. Detecting which object has been hit is as simple as getting the color on the mask and checking which object has that color. This method is especially good for detecting single pixel locations, interacting with objects that are irregular in shape. Using this code file as a stub, make it so that a white X or crosshairs is drawn on the screen with the center being the hot spot of the mouse so it can be moved around by the user. Make it so that if the center of the X touches any pixel of the bricks, that brick is deleted. Have